Now here we have the other triangle of power or special right triangle, where we have two sides being being the same length and two angles being 45 degrees. So we're gonna use different approaches to solve this. Starting with the simplest, and I'm just gonna go back to using a basic example like having this side as 7. If you have 45 and 45, it means that this is an isosceles triangle, that it has two sides with the same length. So that is 7 and 7. So that is kind of like a 2 for 1. And this side is always the length of any of those two sides times the square root of 2. So if you have this, it's going to be 7 times the square root of 2. That is when you're given those sides. Now, let's say this side is 3 times the square root of 2. That would be, once again, a simpler scenario because this is equal to x times the square root of 2. So we already have the square root of 2. So if we solve for x, we're going to have 3 times the square root of 2 over the square root of 2. And the answer would be 3. So the answer, or the meaning of that, is that those two sides would be 3. Once again, very simple to approach whenever the values are easy to spot. But what about this one, where we are stating that x, multiplied by the square root of 2, we get 3. And we need to find an x that makes that happen. So we need to solve for x. And x is going to be equal to 3 over the square root of 2. And if we rationalize that answer, that's going to be 3 times the square root of 2 over 2. So if we know x, we already know that this side is 3 times the square root of 2 over 2, making this side as well 3 times the square root of 2 over 2. So this one, because two sides are the same, is going to be faster once you know x. Now, the last approach is to simply use sine, cosine. So if you know that sine of 45 degrees is equal to, and let's use the opposite by hypotenuse. You can change x into whatever value you want. So if x is 1, you're going to have this as 1 over the square root of 2, and rationalizing that is going to be the square root of 2 over 2. So we know that sine of 45 is the square root of 2 over 2. So the sine of 45 on this triangle as well has to be the square root of 2 over 2. So sine of 45 is equal to the square root of 2 over 2. So that has to be true for this triangle. So sine of 45 has to be equal to a divided by 3, meaning the opposite divided by the hypotenuse. And if I know that that statement needs to be equal to the square root of 2 over 2, so I'm going to substitute this over here, making sine of 45 simply the square root of 2 over 2 equals a over 3. So that if I solve for a, I'm going to have 3 times the square root of 2 over 3 times the square root of 2 over 2. So that means that this side is 3 times the square root of 2 over 2, making this side as well 3 times the square root of 2 over 2. So any method that you use is going to lead you to the same answer.